Welcome to qnawire.
All right, we've got to assess the solvents that were shown here for the following molecules. So first we have, I don't know, some kind of sugar it would look like. 1, 2, 3, 4, 5, 6. And we're asked what the better solvent is. And the first option is methanol, and the second option is THF, tetrahydrofuran. And what we want to notice is that this solvent is capable of hydrogen bonding more readily. It's both a donor and an acceptor. Right? It's an acceptor because it has lone pairs, and it's a donor because there are bonds between oxygen and hydrogen or nitrogen and hydrogen. Right? This is a donor and acceptor. This is also a donor and acceptor. This is just an acceptor, right? Because it has lone pairs on oxygens. So in terms of good solvents, if our molecule of interest is capable of hydrogen bonding, then we want to find a solvent that's capable of hydrogen bonding in both senses of the word, being a donor or being an acceptor. Okay, methanol is both. Tetrahydrofuran is only one. It's only an acceptor. So the better option is methanol. First option, CH3OH. Okay, let's look at our next set of molecules and or solvents. So now we've got this sort of double amide. Okay, and once again, we see a molecule that is capable of being both a hydrogen bond donor and acceptor. It's a donor because of its NH bonds, and it's an acceptor because it has lone pairs on nitrogen as well as lone pairs on oxygen. Okay, what about our solvents? Well, we have got this triethylamine. Okay, and we have got acetone. So the question is, which of these will be the better solvent? Well, I would wager that the acetone will be the better solvent. And this is because acetone is going to be more polar. More polar. There is some polarity to triethylamine. If we recall, this is actually somewhat planar, like nearly planar, with a lone pair on top. Right, so it's sort of like trigonal bipyramidal. So a lot of the electronegativity of this will be directed upwards, but it'll also be slightly canceled out by these three groups. It's not as polar as acetone. Let's say that. Okay. The other thing is that this has two lone pairs for acting as a hydrogen bond acceptor. Well, this only has one. So if I had to hazard a guess, this really isn't a very straightforward question, unlike the previous one. But I'm going to say acetone is definitely the superior solvent, and that's also just from experience in labs. Acetone is pretty much a great solvent for literally everything. TEA, triethylamine is not a super common solvent. That's for a reason. It's just not a great solvent. Okay, let's look at this next one. Okay, now we've got sodium chloride, which we know to be an ionic compound. That is sodium plus and Cl minus, meaning we're looking for something that is very polar, right? And what we have is some very long chain alcohol. Let's see, 5, so 6. So this is like hexanol. 1, 2, 3, 4, 5, 6. Hexanol. And then we have methanol again. Okay, well, recall that these long carbon chains, even if they are eventually terminated in an OH, are relatively nonpolar. right? And that's true of this part of the methanol as well. This is nonpolar, but we see that we have a greater amount of nonpolar bulk to our solvent, right? So in terms of polarity, the shorter alcohol is going to be much more polar than the longer alcohol, right? So MEOH, more polar. And that's the one we want, methanol.